Okay, the second part of 11.2, we're gonna talk more about arcs and chords, but specifically we're gonna talk about congruent arcs. Congruent arcs, as you guessed it, are two arcs that have the same measure. Surprise, surprise. Okay, so in this figure you can see that ST is going to be congruent to UV, and the reason why that is, remember, is that arcs have the same measure. The measure of the arcs are going to be equal or congruent to the measure of the central angle. So what we're going to see is we're going to have a relationship between the arcs and the central angles. If these angles are congruent to each other, then that means that these arcs are going to be congruent to each other. And we can talk about that using our tick marks as well. But something else happens too. If I draw a chord from this point to this point, so if I talk about chord ST or line ST, guess what? That's going to be congruent as well to chord or line UV. So there's three things that are going to be congruent to each other. The arcs, the central angles are going to be congruent. The arcs, if they're congruent, then the arcs are congruent, and the chords are congruent. Okay, so there's three things. If one of these are congruent to each other, then that means that all of these are going to be congruent to each other. And in your book, they give you a picture that looks like this. Okay, so in a circle, or if we have congruent circles, you know, if they're the same, then all these three things are going to be the same. So if we have congruent angles, that's what this picture says. If we have congruent angles, then we're going to have congruent segments. And these segments, notice, are within these central angles, these chords. Okay, so if the central angles are congruent, then the chords are going to be congruent. If then, okay, if the chords are congruent, oh my gosh, that means that the arcs are going to be congruent. That's my congruent sign. So if in this picture you see, if we have that these chords are congruent, then these green things, these arcs, are going to be congruent as well. And then the last thing, if the arcs are congruent to each other, then that means that their central angles are going to be congruent to each other. Okay, so these three things have a great relationship. Again, if one of these things are congruent, then all of these things are congruent. So if the central angles are congruent, then that means that the arcs are going to be congruent. And that also means that the chords within them are going to be congruent as well. And notice, see, when I mean within them, that means it's not going beyond the arc or the central angle. Okay, so these are going to be interesting and easy for some people to solve. Notice we have congruent chords, so that means the arc within that chord, touching that chord, cutting off the arc, is going to be congruent to each other. So all you have to do is say 9n minus 11 equals 7n plus 11, and solve from there. So subtract the 7n, add an 11, and we get 2n equals 22. We solve and we get n equals 11, and some people are going to stop there, but not you, because it says find the measure of arc WS. So all we have to do is plug it back into WS. 7 times 11 plus 11, and we get 88 degrees as our final answer. Remember, when it says measure of arc WS, that means we're talking about an angle. Whenever you see this little m, that means we're talking about angle, which means we're talking about a degrees. So put it in degrees. Your answer will be in degrees. Okay? Segments, we're not talking about degrees. All right, so for example, for this one, it tells you that these two circles are congruent. Circle C is congruent to circle J. Nice. And it says that these central angles are congruent to each other. So if they're congruent to each other, then it says find NM. So NM is a segment. This is a segment. Notice there's no little m, so we're not talking about degrees this time. We're talking about length. So our answer will not be in degrees. Okay, so if we have congruent central angles, that means that these arcs are going to be, that these segments are going to be congruent to each other. The arcs will be as well, but we're talking about segments. So all you have to do is say 14t minus 26 equals the 5t plus 1 and solve from there. So subtract a 5t, add a 26, and you're going to get 9t equals 27. And then we get t equals 3, and then it says find NM, so the last thing you have to do is plug it back in, and you should get 16, not 16 degrees, 16. This segment is 16. Arcs and arcs and central angles will be in degrees. Line segments will just not be in degrees. They're just in units. Okay, one more. It says PT, ray PT bisects RPS. Bisects, such a good word, because that means it's going to cut it into two congruent pieces. So that means that this angle equals this angle, and these are central angles because they are touching the center, and they are formed by radii. It says find segment RT. So we want to find a segment, so our answer will not be in degrees. All right, so if these are congruent, that means that these pieces have got to be congruent. So all you have to do is say 6x equals 20 minus 4x and solve. I think you guys are getting the point here. So the next one, you're going to title this number 3 because it's, no, I'm sorry, number 4. This is the fourth example. Might be on your quiz tomorrow. Go ahead and answer this question in your notes and you'll be ahead of the game for tomorrow. All right, last thing we're going to talk about are chords. Remember, a chord is something that hits the circle 2 times. So we're going to talk about the relationship between chords and the radius or diameter. This is what I would title these notes. Okay, if a radius or diameter, excuse me, is perpendicular. Perpendicular means it meets at right angles. So if you notice CD is the radius, it's perpendicular. Then 2 things are really cool that happen. 1 is it bisects the chord. 2 is it bisects the arc. So that means that this piece is going to be congruent to this piece, and that means that this chord is going to be congruent to this chord. Super important. Okay, so how I would write that in my notes is to say if a radius, and I'm also going to write diameter, is perpendicular to a chord, then that means that the chord is bisected or cut in half, if that makes sense to you, as well as the arc. The chord and the arc are both bisected. And this one just says the opposite of it. So if we have a chord and it's being perpendicularly bisected by something, so it cuts it in half and it meets at a right angle, then that has to be either the diameter or the radius. Okay, so how I would write that in my notes is if a chord is perpendicularly bisected, meaning it hits at a right angle and it's cut into 2 congruent pieces, then the segment bisecting it, cutting it in half, not the chord, must be either the diameter or a radius. Okay, so what that means we can do, here's an example. What that means here is this blue line is not going to be given to you. You're going to see this and you're going to see a chord. And we know that RM is the radius. And we know that NP is the chord. And what's happening is the radius is perpendicular to the chord. So when that happens, that means that the chord is going to be bisected into 2 congruent pieces. So that means that this piece is going to be congruent to this piece. Now we know it's kind of hard to see, but this is 8 and this is 9. RS is 8 and SM is 9. So we want to figure out how long the whole chord is. So what we're going to do is we're going to draw another radius. That's what this blue line is. Because if you know RM is the radius, well, 8 plus 9, the radius equals 17. So we're going to use that to our advantage. What we're going to do is we're going to draw a triangle. And I know that this radius is 17. That was the first thing I did, was I found what the radius is. 17. Then I'm going to use Pythagorean's theorem to figure out how long this part is, because I already know that this part is 8. So I do my Pythagorean theorem, x squared plus 8 squared equals 17 squared, and I think I get 15, if I'm correct. 8 squared plus 15 squared, 17 squared. Boom, I am correct. Okay, so I get that this piece is 15. The last thing I have to do is I have to remember, well, it's being bisected. So 15 times 2 is going to be 30, and then I'm done. I know I went over that really quickly, but remember, this chord, if a radius hits it, perpendicularly, it'll be bisected. So if this part's 15, then this part's 15. The last thing you're going to do tonight is title this number 15. I wrote out all the steps for you. Draw the radius, use Pythagorean's theorem, find QR. This will be the last one on your quiz tomorrow. That could be on your quiz tomorrow. So this is an overwhelming amount of information about arcs and chords, but I'm sure you feel like a much better person because you watched the video. Thank you.